All right, here we are, IXL EE.6, simplifying radical expressions using distributive property. All right, so remember, distributive property is what we get. I'm going to do a really simple one just to make sure we remember. Something like this, where there's something on the outside and then some stuff on the inside. Distributing is when you take the thing on the outside and you multiply it with everything on the inside. So for this one, we would do 2 times x, which is 2x, and then 2 times 2 is 4. And that would be the answer to that. All right, so that's the distributive property. Multiplying everything on the inside with the thing on the outside. So here's what we're doing here. So we've got the parentheses, we've got something on the outside, we've got some stuff on the inside. All right, so we're going to be multiplying the outside thing with both things on the inside. All right, so we're going to do this. So this would be negative square root of 3 times negative 4. So when we're looking at these numbers, you've got 2 types of numbers here. You've got numbers in the square roots, and you've got numbers outside square roots. You cannot multiply numbers if they are in different places. So I've got 1 outside, 1 inside. Can't just multiply those and get 12, right? If you're going to multiply them and combine them, they have to be either both outside or both inside. So for this one, these are not the same, so I can't do that. What I can do is negative times negative is a positive, so kind of like that disappears. And I'll just have 4 square root of 3. Just like we had the 2 and the x, and we just wrote 2x, kind of just wrote them next to each other. Same thing here. 4 square root of 3 here, right? The negatives went away because the negative and a negative make a positive. When I do the second one, I've got negative square root 3 times negative square root 3. So again, 2 negatives make a positive, so we'll have a plus sign in the middle. Now these numbers, they are both inside. I'm going to write them like this. They are both in the square root, so we can write them in the same one. Since I have 2 of the same number, that's a pair. Remember, pairs get to go to the outside. So this one's going to turn into 4 square root 3 plus 3. There's no leftovers in the root, so the root goes away. So the answer here would be 4 square root 3 plus 3, right? I cannot add these together because this one does not have a square root of 3, right? It's like terms. You can't combine like terms, and square roots count as those. Just like I did not add these together to get 6 because the 4 did not have an x on it. It's the same thing when we're dealing with the roots, right? So that is the final answer there. For this next one, same idea. We're going to distribute that. So we've got square root of 35 times negative 5. So I'm going to write them, just write them next to each other. The square root always goes second, right? And then this one, I've got 2 times 35. When you're combining these and you've got bigger numbers like this, you need to do the factor tree just to make sure that you don't end up with any doubles. Like this one, we ended up with double 3s. So they got to leave the square root. So here we want to check to see if we're going to have any doubles now that we added extra numbers together. So 35 is 5 times 7. 5 doesn't break down, 7 doesn't break down. So here you see I have a 2, a 5, and a 7. There were no pairs there, so we don't have any doubles, so we can't do that. So our final answer here is going to be negative 5 square root 35 plus, well, we're going to forget about that. 2 times 35 is 70. And that is your final answer there. All right. This one. So, going to distribute. Negative is positive. 2 on the outside, 35 on the inside. Next one, 2 negatives make a positive. 5 and 35 are both inside. So we're going to check like we did before. 35 is 5 times 7. Then if you look there, now that we added that extra 5, we have a double 5. Which means our final answer, we'll bring that down. The 5 is going to go to the outside, the 7 is going to stay on the inside. So that's going to be your final answer there. Right. Always double check your factor trees. Look for doubles just in case they get to go to the outside. If you were to put this in the answer for IXL, you're not wrong, but you're not done. So IXL will mark it wrong because you didn't finish the problem. Alright, so make sure you check that. Sometimes you'll get doubles like we did here. Sometimes you won't, like this one. So you always got to check just in case, right? Alright, so I'm going to end the video here. Make sure you watch part 2 to see how to do this kind of problem. They're a little bit different, so make sure you watch part 2.